Welcome to ISO 31010, Risk Assessment Techniques. In the next few minutes, we'll walk through the comprehensive toolkit of over 30 risk assessment methods defined in ISO 31010:2019. You'll learn how to select the right technique for your context, from brainstorming and Delphi through FMEA, fault tree analysis, bow tie analysis, Monte Carlo simulation, and beyond. The course uses tech solutions incorporated to demonstrate each technique with practical examples. Let's get started. With over 30 techniques available, choosing the right one is the first critical decision. Let's understand how to select. ISO 31010 organizes techniques into categories based on their primary purpose in the risk assessment process. Elicitation techniques gather risk information from people. Brainstorming generates a broad list of risks quickly in group settings. The Delphi technique uses anonymous expert rounds to build consensus without groupthink. Structured interviews extract detailed risk knowledge from individuals. Surveys reach large populations efficiently. Tech Solutions uses brainstorming for initial identification and Delphi for expert calibration of complex technology risks. Analysis techniques examine how risks materialize and propagate. FMEA systematically analyzes failure modes and their effects. Fault tree analysis works backward from an undesired event to identify contributing causes. Event tree analysis works forward from an initiating event to identify possible outcomes. Bow tie analysis combines both views: causes on the left, consequences on the right, controls in the middle. Evaluation techniques help prioritize and make decisions about risks. Risk matrices provide simple visual prioritization. Monte Carlo simulation models probability distributions for complex scenarios. Decision tree analysis evaluates choices under uncertainty. Cost-benefit analysis compares the cost of controls against the expected reduction in risk. These techniques support risk-informed decision-making. Monitoring techniques track risks over time and learn from events. Key risk indicators provide ongoing early warning. Control effectiveness testing verifies that mitigations work. Scenario analysis explores how emerging threats might affect the organization. Root cause analysis investigates actual events to prevent recurrence. These techniques close the feedback loop in risk management. While ISO 31010 covers over 30 techniques, these 6 are the most widely applicable and frequently used. The risk matrix is the most widely used technique. Plot risks on a likelihood by impact grid to create a visual priority map. It is simple enough for any stakeholder to understand and use. The limitation is that it oversimplifies complex risks and can create misleading prioritization when likelihood and impact scales are poorly defined. Despite this, every risk professional needs to master the risk matrix. Failure mode and effects analysis systematically examines each component or step in a process, identifies how it could fail, assesses the severity, likelihood, and detectability of each failure, and calculates a risk priority number. FMEA is essential for manufacturing, engineering, and process improvement. Tech Solutions uses FMEA for their software deployment pipeline, identifying 23 failure modes and their mitigations. Bow tie analysis is one of the most powerful visual risk tools. The hazard sits at the center. Causes and preventive controls fan out to the left. Consequences and mitigating controls fan out to the right. This single diagram shows the complete risk picture: what could cause the event, what prevents it, what happens if it occurs, and what limits the damage. Ideal for communicating complex risks to leadership. Monte Carlo simulation runs thousands of scenarios using probability distributions for uncertain variables. It produces a range of outcomes with confidence intervals rather than a single point estimate. Essential for financial risk, project scheduling, and any context where multiple uncertainties interact. The course demonstrates Monte Carlo for project cost estimation and cybersecurity risk quantification. Now let's cover how to select the right technique and how to combine multiple techniques for comprehensive assessment. Selecting the right technique depends on your assessment objectives, available data, and stakeholder needs. Start with your objective. Are you identifying risks that have not been cataloged yet? Use elicitation techniques like brainstorming and structured interviews. Are you analyzing how a specific risk materializes? Use FMEA, fault trees, or bow tie analysis. Are you evaluating and prioritizing risks? Use risk matrices or Monte Carlo. Are you monitoring ongoing risk? Use KRIs and scenario analysis. The objective determines the technique category. Available data constrains your technique choice. Quantitative techniques like Monte Carlo require numerical probability data. Qualitative techniques like risk matrices work with expert judgment. Semi-quantitative techniques like FMEA combine both. If you have rich historical data, use quantitative methods. If you are assessing novel risks with no history, qualitative methods are more appropriate. Consider who will consume the results. Executives and board members respond to visual techniques like risk matrices and bow ties. Engineers and process owners need detailed techniques like FMEA and fault trees. Risk committees need both, summary views for prioritization and detailed analysis for decision-making. Choose techniques that communicate effectively to your primary audience. The most effective assessments combine multiple techniques. Use brainstorming or Delphi for identification, FMEA or fault tree for detailed analysis, risk matrix for prioritization, and bow tie for communication. Each technique has strengths and limitations. Combining them provides comprehensive coverage. Tech Solutions uses a standard combination of 4 techniques for all major risk assessments. Understanding when to use qualitative versus quantitative techniques is essential for effective risk assessment. Qualitative techniques use descriptive scales and expert judgment. They are fast, accessible to non-specialists, and work even when historical data is limited. Risk matrices, brainstorming, and structured interviews are qualitative. They are best for initial risk screening, broad identification exercises, and contexts where precise numbers would imply false accuracy. Most organizations start here. Quantitative techniques use numerical probabilities and financial impact values. They require historical loss data or carefully calibrated expert estimates. Monte Carlo simulation, decision trees, and cost-benefit analysis are quantitative. They produce precise results with confidence intervals, enabling financial decisions about risk transfer, control investment, and capital allocation. Quantitative assessment is essential for insurance, regulatory capital, and major investment decisions. Let's close with the most important lessons from ISO 31010. First, no single risk assessment technique covers all needs. Effective assessment combines elicitation techniques for identification, analysis techniques for understanding causation, evaluation techniques for prioritization, and monitoring techniques for ongoing tracking. A minimum toolkit of 4 to 5 complementary techniques provides comprehensive coverage. Second, match your technique to both the objective and the audience. The most technically sophisticated analysis is useless if the audience cannot understand or act on it. Conversely, oversimplified analysis for technical audiences wastes the opportunity for deeper insight. Let the objective guide technique selection and the audience guide presentation. Third, start with qualitative techniques and add quantitative rigor as your data matures. Forcing numerical precision when historical data does not exist creates false confidence. Build your qualitative risk picture first, then overlay quantitative analysis where you have credible data. The course shows this progression using Tech Solutions' 3-year journey from qualitative to quantitative assessment. And fourth, treat ISO 31010 as a toolkit, not a prescription. You do not need to use all 30+ techniques. Select the methods that fit your organization's risk profile, assessment maturity, and available resources. Master a core set of 5 to 6 techniques well, then expand your repertoire as needs evolve. That wraps up our overview of ISO 31010 risk assessment techniques. In the full Udemy course, you'll get 57 detailed lessons covering every technique in the standard, the Tech Solutions case study demonstrating practical application, step-by-step guides for each technique with templates and examples, and a selection framework to match techniques to your specific needs. Click the link below or scan the QR code to enroll and build your risk assessment expertise. Thank you for watching. If you found this overview helpful, subscribe to the channel for more content, and check the description for the link to the full course. See you in the next video.